Okay, this is 14.2, surface area of cylinders and prisms. Remember that the vocabulary box and the summary at the beginning of the lesson is your friend. So looking at this vocabulary, the things that you are going to need to know are what the altitude and height are, lateral area, lateral face, and then you need to know the two primary different types of cylinders and prisms in terms of the being upright or oblique. So you need to know about oblique cylinders, oblique prisms, right cylinders, right prisms, and then in addition to lateral area, then you also have total surface area. The main thing from the essential understanding that you need to know from this unit is how to find the total surface area of a three-dimensional figure. So, and then also find the sum of the areas of all the surfaces of the figure. That, of course, is how you find the total area. Okay, so to get started with this chapter, always take note. When you see take note in the book, this is a very friendly book, you have your key concepts. So you need to know what a prism is. So a prism is made up of two bases and then the lateral faces that connect those bases. The lateral faces, the number of lateral faces that you have is going to be equal to the number of sides that you have for your bases on a prism. So then you also have lateral edges, and which are of course the edges that are the intersections, the segments that are the intersections of the lateral faces. Okay, now the altitude of a prism, just like with a triangle, is that perpendicular segment that defines the height of your prism. It connects the planes, joins the planes of the bases. Now, the height of a prism is just a definitional term, is the length of an altitude. So now you can either have a prism that is right or oblique. If a prism is right, the lateral faces are rectangles and the lateral edge is going to be your altitude. So the faces are parallel to your altitudes. In an oblique prism, some or all of the lateral faces are non-rectangular, and what ends up happening is that they are also not parallel to the height or the altitude, right? In this book, and generally in geometry courses, unless it's otherwise stated, you should assume that a prism is a right prism unless it's otherwise stated or in the picture, okay? All right, lateral area is the area that's talking about the faces of your prism. So that is all of the area except for the bases. A quick way to find lateral area is to do the perimeter of the base times the height of the prism. The total surface area is going to be your lateral area plus the area of the two bases. So LA plus 2B. So we'll be using this in some example problems. Okay, now for a cylinder, cylinders also have two bases, but you don't talk about cylinders having faces, lateral faces. A face really needs to be a polygon. So in this case, we don't have a lateral face, but you do have lateral area because it is the area that's connecting the bases. So right cylinder is oriented where the height of the cylinder is the length of an altitude, sorry. The segment joining the centers of the bases are an altitude. In oblique, the altitude is different from the segments that connect the bases. Again, in this book and in all other classes of geometry in high school, unless it says otherwise, assume it's a right cylinder. Okay, one more key concept and then we will work some examples. And that is, you need to know the lateral area formula for a cylinder as well as the total surface area for a cylinder. Lateral area is going to be 2 pi r. Okay, what is that? That's just the circumference of the circle, which is like the perimeter from our prism formula, times the height. Or the lateral area can also be described as pi times the diameter times the height, because of course that's your other formula for circumference. The total surface area for a cylinder is going to be the lateral area plus 2b, or I prefer this, 2 pi r h, so that's the that is your formula for the lateral area, plus 2 pi r squared. Pi r squared, you should recognize that. That is the formula for the area of a circle. Okay, so to sum up, our formulas so far. You will want to have a sheet where you are gathering your formulas for chapter 14. This will help you as you do your homework, as you're learning the unit, and then of course, for any open note quizzes or tests. So far we have Euler's formula. And this is for three-dimensional. We have the faces plus the vertices is equal to the edges plus 2. And now we have some surface area formulas. Okay, prism. Okay, our lateral area is equal to the perimeter of the base times the height. Our total surface area is equal to the perimeter times the height plus the area of the two bases. Okay, for a cylinder, your lateral area is equal to 2 pi r times the height, or pi times the diameter times the height. And your surface area is equal to 2 pi rh plus 2 pi r squared. Okay, these are our formulas so far for this. Now, there are different ways to find surface area. The most straightforward way you're going to find is probably using the formulas based on the information that you have. But it's important to understand the relationship between three-dimensional objects and their two-dimensional nets. So, using a net to find the surface area of a three-dimensional figure. Part of what's going on here is you need to know how to draw a net from a three-dimensional figure. So let's say that we have a rectangular prism. So this is not going to be in a right one. That would be oblique. I want mine to be right. So let me redraw that. Okay. Problem 1. So if we wanted to do the net for this, there are a couple different ways to do this. What I like to do is to take one lateral edge and then put two bases on either side of it and then lay out the rest of them. So if we have our dimensions, which are 4 by 3 by 5, we take our 4 by 5, and then we have on our base on the top is 3 by 4, and then our base on the bottom is also 3 by 4. And then we have each of our lateral faces. So we have this one, which is 3, and we have the next one, which is 4, and then we have our last one, which is 3. Each of these would line up with a side of the base. Now, surface area using a net is going to be the sum of the areas of all the faces. So in this case, if we figured out the sum of the areas of each of these, this would be 12, 20, 12, 15, 20, 15. So we would add all of those up. Oh, too many 20s. So 40 plus 24 plus 30 is going to be 94. And in this problem, these were centimeters, so this would be centimeters squared. Okay, now, so that's how you would use the net. What if we just wanted to take a three-dimensional figure and find the area, surface area of it using our formulas? Okay, there are surface area formulas. So let's say that we have a prism that has bases that are right triangles. Okay. Now, first, we want to find the perimeter of the base because we're going to be using to find the surface area of this, we're going to practice finding our lateral area, and we're also going to find our surface area. Lateral area is the perimeter of a base times the height of the prism. Now, looking back at our net real quick, let's see why that might be true. So if you take a look at this net, and I were to add we have one long rectangle if we put all of these together, right? And this entire side would be 4 plus 3 plus 4 plus 3, which would be 8 plus 6, which is 14. And 14, of course, because this over here is 3 and 4, that's the perimeter. And so I can either find each of these rectangles separately, or I can say I have one big rectangle that wraps around my entire three-dimensional figure as the lateral faces. And so I can take the perimeter of my base and multiply that times my height. Okay, now back to this problem. So in this problem, our bases are triangles. And so our perimeter is going to be the perimeter of this right triangle. Now, I recognize that this right triangle is a 3, 4, 5 right triangle. So I know then that the perimeter is going to be 3 plus 4 plus 5. So that is 12. And this is centimeters again. And then my height is 6. So to find my lateral area, I would take my perimeter, which is 12, and my height, which is 6, and I multiply those together and I get 72 centimeters squared. Now the surface area, remember, was the lateral area plus the two bases, the area of the two bases. So my lateral area plus the area of my two bases. Lateral area. Now, if I had a problem where I wasn't being asked to find the lateral area separately from my surface area, I would go ahead and substitute in the fact that this is supposed to be pH plus 2b. And I would do all of this at the same time instead of finding my lateral area separate from my surface area. So I'm going to pretend like we don't already know that our lateral area is 72 and go ahead and substitute in all of our information. So we've got 12 times 6 times the area of my two bases. Now, what is the area of my base going to be? Those are right triangles. So my area of my base is 1/2 BH. Now, you are welcome to take this and substitute it in for your B, or you can solve for B first and then put that number in. I'm going to solve for B first and then put the number in for the area of my bases. So 1/2. One of my bases, remember, are going to be the segments that are on a right triangle that are perpendicular to each other. So 1/2, 3 times 4, so that's 6 centimeters squared. So up here, I would have plus 2 times 6. Okay, so I have 72 plus 12 is 84 centimeters squared. Okay, so that's how to find the surface area of a prism. How about finding the surface area of a cylinder? So, okay, surface area of a cylinder. Okay, the radius of the base of a cylinder is 4 inches. So our radius is equal to 4 inches. And the height is 6 inches. Okay, find the total surface area in terms of pi. When it says in terms of pi, that means you're going to leave the symbol pi in your answer rather than substituting in its value and multiplying it out. Okay, so I know then that I have a cylinder. That was a terrible cylinder because my bottom circle is bigger than my top one. 4 inches. For the radius, and the height is 6 inches. Okay, so if I wanted to find my lateral area, I would say that that was 2 pi r times the height. Now, if I want to find my surface area, I'm going to have the lateral area plus the 2 bases. So my surface area will be 2 pi rh plus 2 pi r squared. So I have 2 pi times the radius, which is 4, times the height, which is 6, and then my radius squared. Okay, working that out, I have 4 times 6 is 24 times 2 is 48 pi, plus 4 squared is 16 times 2. That's 32 pi. So then I have 48 plus 32 is 0, carry the 1. That is 80 pi. And this is inches squared. Okay, so that is finding the total surface area of a cylinder. There is one more example where there's an application of the area of a cylinder. I'm not going to go over that at this point. If you need to go look at that problem in your book in order to answer your homework questions, go ahead and do that. The main thing that you need to know from that is that it's important to understand, just like the paper wrapped around maybe a can of food, you can take that off and flatten it out. What shape will you have? Well, you'll have a rectangle. And that rectangle also forms part of the net of a cylinder. So likewise, if you have a roller and you are using that to paint with, when your roller paint goes onto the wall, it makes a rectangle. So then, worth noting is, what does the net of a cylinder look like? What is the net of a cylinder? Well, you have your lateral area, right, which is a rectangle, and then you have circles, which, if my paper didn't run out, would both be the same size. And of course, this is going to be your circumference, and this is your height. All right, let's take a look at what you need to do for your homework for this unit. Okay, in your homework, you need to be able to find surface areas from images that are given to you, right? If they give you a figure, you need to use those dimensions to get the surface area. You can use the net method, or you can use a formula for these. All right, you need to be able to classify polyhedron. You need to be able to also use the formulas, in this case, to find the surface area. I recommend that you try using the net, that you make a net of each of these that are assigned so that you get some practice with that. Then be sure to notice whether it's asking you for lateral area or total surface area in the problems. Finally, on the next few pages, there are some word problems where you're asked to apply your knowledge to various situations and to decode those word problems. Okay, that's it for 14.2. Have a great day.